Hey, what up guys, it's YOLO version 3 series part 5 and it's Ivan here. Why is Ivan here? I'm here because it's about the time that we actually start training YOLO version 3 model, and I'm gonna show you just the way to do that. So, in the last videos we've learned how to get the images, install darknet, and label all the training data, and it's time to put all of the pieces that we've put together and actually get the whole thing going. So the whole process will be made of like 3 main steps. We're gonna modify the CFG file. I'm gonna show you how to do it for both YOLO version 3, the big one, and YOLO version 3, the tiny version. Then I'm gonna show you how to put all the data in the right place so that YOLO can actually refer to the all those beautiful bounding boxes and the training images that we've got. And then last but not least, we're gonna learn how to actually get it running in the terminal, what commands to give it. And then as a bonus, I'm gonna show you how you can interpret the YOLO version 3 output on this example that I've got from Google Colab while training this my most recent model for detecting the bus numbers with YOLO. So without further ado guys, let's jump right into it. So okay folks, actually I think we'll start off by actually putting all the data that we've got in the right places so that YOLO may actually learn from it when it comes to training, because when you don't have training data, life's kinda tough. So let's say we've labeled a bunch of images, something like that, whatever is like your spiel, and your images. Here I have I have actually a lot more images, but in this batch I have like 300 images and 10 classes, obviously 0 through 9 for the digits. So let's go ahead and close this thing. So I've done an open labeling, so I have all of my bounding boxes sitting nicely here and all of the images here. Now let's go to the darknet master build, darknet.exe data. And I mean, if you're on Linux, you're gonna wanna go to this data folder, and the closest data folder that you have to your darknet that you're actually will be using, since we're on Windows and we're in this repo and we have our darknet node GPU.x here. That's what I'm gonna be using. So I'm gonna put all this stuff in this data folder. So before we actually create this obj folder where we're actually gonna put all of our labels, here's the little program that we have here that will basically generate the train.txt file that YOLO version 3 needs with paths relative to darknet, that to basically darknet that will be launching, to actually know like what are the images that we have that it can refer to and like work with. So it's like a super simple program that goes through all the images that we have here, and it basically generates the train.txt file with all of the paths relative to the darknet. So let me just run it. And there will not have it, but let me run it again. There we have it. So the train.txt file is gonna look something like that, and yep, it's basically all of our images. So let's go and put the train.txt file to our data folder. Just paste this guy here. I already have this guy from the whatever the previous training that I've done, but It's good. It's all good. So object now, for actually giving the images, we'll just go and copy the images from here, put them here, and copy the labels from here and put them right over here. And we're basically like putting them in the same folder, so it's all good. So we've got our train.txt file with all the paths relative. You can see that kind of here. Like, we have our darknet here. Here, go to from our darknet. Oh boy, that's a mess here. But darknet here, data, obj, and the same stuff kind of gets here, data, obj, and all the files. So now that we have done that, we can actually go and create several other files that we will need, and that'll be a file such as obj.data, and we're gonna want to put something special there. So in this, here I'm basically following the awesome documentation from Alexei AB's darknet repo, so we'll basically just go ahead and copy. I'll probably leave something in the description, but here's what we need to put in the obj.data folder. So I'll just go here, open up obj.data, and basically put all of the text here. So in my case we have 10 classes, so I'll put 10. If you have 3, you put 3. If you have 987, you put that exact number there. So our train file will be in data train.txt. The validation data set is not necessary, so I don't usually use that, and prefer to kind of test the performance of the model by giving it images, but you may want to do that. So in here you can see there's another file, obj.names, that will have to specify. And in obj.names, what will actually gonna be put in there is pretty much the names of our classes. So it's really intuitive. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you have just 2 classes, it's like cat, dog, or like I don't know. Wait, are there spaces? Where are there spaces? We don't need no spaces here. So again, let me just go back. So if you're like have rabbit, dog, cat, you do that, like 3 classes. I have 10, so that's my layout for my specific classes. And that's actually it when it comes to data. When it comes to like putting the data in the right folders, we've got our object folder with all the files and labels. We have our train.txt here. We have our object.names, our object.data. And now let's actually get to modify the CFG file. So here in our folder we have all of the CFG files, and I'm gonna be showing you an example based on YOLO version 3 tiny model, but the steps are really similar for the big version as well. It's basically the same logic that applies. So for the YOLO version 3 tiny model, it's recommended to start it off from using this YOLO version 3 -tiny underscore obj.cfg from the documentation. So that's what I'm gonna do here. I'm just go and paste it here. So guys, now the fun stuff begins. Now we're actually gonna modify the .cfg file so that the model can actually work with our number of classes, and like all of the stuff can work correctly. So let's go ahead and rename our YOLO version 3 -tiny into YOLO version 3 -tiny obj.cfg. If you have YOLO version 3, just go with YOLO version 3 obj.cfg. Like no big deal here. So let's go ahead and open up and editor that you choose to use. I use PyCharm. So yep, there we have it. So in here are actually all of the instructions that we need to, follow to modify the CFG file successfully. So first of all, we change the batch to be x64 here and subdivisions to be 8. Yep. Then and then here's the thing, like the YOLO version 3 model has several YOLO layers. To be precise, the tiny model has 2 layers and the big model has three YOLO layers. And before each YOLO layers we need to, and in each YOLO layers we gotta modify the number of classes, and we also gotta modify the number of filters before each YOLO class. And for the big YOLO you kind of do that 3 times, for the tiny YOLO you do it just 2 times because there are 2 YOLO layers. Common sense. So let's do that. So for instance, in the first YOLO layer you modify the amount of classes to be 10, and the amount of filters you modify according to this formula here. So it's classes plus 5 times 3. In my case we have 10 classes, that'll be 15 times 3, and that'll be 45. Just go and do the same thing here. Yep. But the fun stuff isn't over yet, because as you can see there are those anchors that we have in each YOLO layer, and anchors are basically the ratios of width and height that YOLO uses to predict width and height when it, in the real-time cases. And it's actually quite recommended, and I always do that. Basically I compute anchors for each training data set. So basically if you have a training data set, you compute anchors for it, and you train YOLO with its anchors, and then you deploy the same YOLO version 3 model. And if you modify significantly your training data set, it's recommended to recompute the anchors. So that's what I'm gonna show you how to do now. So let's go ahead to let's launch our darknet. In my case it's no GPU.exe. Then we'll say detector called anchors, and we gotta basically give it the path to data obj.data, then num of clusters. Num of clusters is basically number of pairs here. So the tiny model has 6 of those and the big model has 9 of those. So we'll say num of clusters here 6, and width will be 416 and height will be 416. Yep, because that's the input resolution for YOLO version 3. So let's go and run this thing. So it will compute the anchors, and then we'll paste these exact anchors to each of the YOLO layers. And that's it, we're done modifying the CFG file. Now the only other thing that's left for us is to, if you're training the big YOLO version 3 model, then we gotta get the weights, right? So if you're training the big model, you can go, and I'll leave the link, and download this pre-trained convolutional weights. And if you're training the tiny YOLO version 3 model, you can go and download where is that? Okay. Go and download YOLO version 3 tiny weights, and then we can kind of extract all of the convolutional pre-trained weights that we need from there. So let me kind of show you what I mean. Okay, so here I have YOLO version 3 tiny weights that I've downloaded from the official website. Go here and we basically give it this command. That'll be basically be this command here. So we get no GPU partial CFG YOLO version 3 dash tiny CFG weights. We've basically taken the 15 convolutional layers. I think that's how it works. Oh, let's go. So let's save the weights to YOLO version 3 tiny.conf.15. And guess what, guys? Like, at this point we can actually just go and run the whole thing in the command terminal. It wasn't that long and it wasn't, that scary. But, it first took me some time to figure this stuff out. But let's actually see how we can start training. Now, here's some, real life stories. So I've actually tried to do that video before, and at the end of it, I launched this thing on my computer while recording, while having all the programs opened up. And as you may have guessed by, the way I call darknet, I've got no GPU. So basically my computer, it didn't blow up, but it was kind of close to blowing up. Basically everything installed, and I've lost all the video because, my computer, decided not to work. So I'm not gonna launch it here, but I'm gonna show you the command, and I'm gonna show you, how to read the output from the collab screenshot that I have got. So how do we actually start training? We'll say darknet no GPU.exe, and we'll say detector train. Then first of all, we gotta give it the obj.data folder, obj.data. Then we'll give it YOLO version 3 tiny obj.cfg. Then we'll give it YOLO version 3 tiny.conf.15. And just let me verify. Yep. So like if you're training your stuff on Google Colab, you may wanna kind of put a don't show flag here so that there is no OpenCV window showing you the output, and there's just the writings in the command terminal. I'm gonna just leave it here, but that's basically the command. You give it the you call the darknet detector train. You give it the path to data obj.data. Then obj.data connects with the train.txt file and with the obj folder where all your where all your stuff lies, where all the training data lies. Then you give it your modified CFG file, the pre-trained convolutional weight of the convolutional layers, and you may or may not want to give the don't show flag here. So that's kind of it. Now let me kind of give you an idea as to what the output means. So when it comes to output, what you'll see is the number of steps, the number of steps that YOLO has made so far. Basically the number of batches that it processed, and batches have 64 images, so this number here is basically this number times 64. That'll be basically the the amount of images that it went through. So this guy here is the loss for the current batch, and this is the average loss for it kind of gets summed up over all of the batches that it goes through. This is the learning rate. This thing, and this is the the amount of seconds that it takes to process a batch. So as a rule of thumb, you want the average loss to go down, and when you start your loss maybe like 1500 or 600 or whatever that may be, and you want to have it go down over time. Sometimes it may spike up, and sometimes it may just go like fall down drastically. But overall, if it goes down, then everything works and it's fine. But if there's a you know, when it comes to like this average loss, then something's not going well, you know. However, if there's an end here in the, you know, in the like each region that it processes, then like that's okay, because for instance here it has no images, and thus like there's just no average intersection over union thingy. So you may just Google what intersection over union thingy means, but basically it's a measure for object detection, you know, algorithms to kind of measure their performance, and the bigger this average IOU, the better it is. So basically, you know, let's hope that the loss will be coming down, and that it will not be a NaN value, and that will not be a NaN value for like a dozen of consecutive iterations, because then, you know, nothing good is likely to come out of that. And if that happens, you may want to like relabel your training data or find some bugs, or you may ask me questions in the comments or hit me up on Twitter, and I'll be happy to help. Hey, what up? It's basically me from the future coming to tell you that the weights will be automatically saved to backup folder every 100 iterations, no matter what. If you like hit them, they'll be here in a backup folder, so no worries about it. And I'll just now go to the past or the future, or just turn right and go there, or just, you know, kind of slide down. Yeah, I like sliding down, so that's what I'm gonna do. So that's pretty much all I've got. Now we can actually start training your custom YOLO models, and I'm really excited for you. Like let me know what you're working on, and what is your purpose, like what is your purpose for, you know, learning YOLO, like what do you want to put together with it. Ask questions, I'm here to help, and you know, all the stuff in the comments or on Twitter or whatever works best for you. And yeah, thank you guys for watching. I wish you all the best stuff that I can, and yeah, bye guys. I hope you enjoyed it and that was useful.